Limiting reactant. So some vocabulary we have. A limiting reactant. A reactant is the same thing as a reagent. It limits how much product you can form. So it limits the reaction. An excess reactant or an excess reagent you have extra of. So you're going to have some leftover. So it doesn't tell us how much we can form in a reaction because we're going to have more than enough. You know it's a limiting reactant problem when you have two givens that go with two reactants. So when you have two givens that go with two reactants, you're going to take both of your givens and convert them to moles. Then in your head, you're going to divide by their coefficients. We don't want to write that number down, but whichever one is the smaller amount is your limiting reactant, which automatically makes the other one the excess reactant. So if we look at an example, so HF is exposed to, so we're going to add SiO2. So that's going to turn into water and silicon tetrafluoride. Now I wouldn't expect that you would know how to write that reaction. That one's a little bit of a different type of reaction. So it would have been given to you. So then we're going to balance it. So if we start with our fluorines, we have 4 fluorines, so we'll put a 4 there. That gives us 4 hydrogens, so we'll have to multiply by 2, which gives us 2 oxygens, 2 oxygens. So we have 2 moles of HF, and we have 4.5 moles of SiO2. The first part of the question wants me to figure out which one is a limiting reactant. So I need to make sure that I'm in moles, and we're in moles, 2 moles and 4.5 moles. So now in our head, we're going to divide by the coefficient. So 2 moles divided by 4 gives me 2. 4.5 divided by 1 gives me 4.5. The one that's the smaller amount is the limiting reactant. So that would be HF. So we can say HF is our limiting reactant, which makes SiO2 the excess reactant. The second part of the question says how much water is formed. So now I'm looking for information about water. When it says how much, they're asking how many grams. So the limiting reactant limits how much water I can form. So I'm going to start with my limiting reactant. So I don't need the information about my excess. So I have 2 moles of HF. In stoichiometry, the first step is to convert to moles. We're in moles. The second step is to use the mole ratio to go from our starting substance to the substance that we want. And then the coefficients are used. So 2 in front of the water, 4 in front of the HF. So now I'm at moles of water, but I don't want moles of water, I want grams of water. So now I'm going to convert moles to grams. So 2 hydrogens and an oxygen has a molar mass of 18. That's for every 1 mole. So now I'm at grams of water, so I'm done, and I'm going to multiply and divide, multiply and divide. So I have 18 grams of water. Here's another example. Chlorine reacted with sodium. Remember, chlorine's a diatomic. So this is a synthesis reaction because I'm adding 2 elements together, so it's a binary synthesis reaction. Sodium has a charge of 1, chlorine has a charge of 1, so it would be NaCl. To balance it, I would need to multiply by 2 and 2. So I have 25 grams of chlorine and 20.5 grams of sodium. Which reactant is in excess? So the first step is to convert to moles. In our first example, we were already given moles. So the molar mass of chlorine, and since I have 2 of them, 35.5 twice, is 71.0 for every 1 mole. So that gives me 0.289 moles of chlorine. We're going to do the same thing for the sodium. Molar mass of sodium is 23. And that gives us 0.891. So again, in our heads, not with our pens, we're going to divide by the coefficients. So chlorine's coefficient is 1, so that would give us 0.289. Sodium's coefficient is 2, so if we divide sodium's moles by 2, we would get 4 point something. Well, 0.2 is going to be less than 0.4, so chlorine is my limiting reactant, which means sodium is my excess reactant. The second part of the question says, how much product can you form? Again, how much means grams. The product is NaCl. The arrow points to the products. The limiting reactant is going to limit how much NaCl I have. So I want to use my limiting reactant. And so stoichiometry says first be in moles. So I don't want to start with my 20.5 grams because I'm just going to go ahead and convert that to moles. So I can start here and then use my mole ratio to change from chlorine to sodium chloride, the coefficients. But I don't want moles of sodium chloride, I want grams of sodium chloride. So then I can convert to grams by using the molar mass of chlorine or of sodium chloride, which is 58.5. So now I'm at grams of chlorine. So now I can multiply and divide, multiply and divide. And my answer would be 33.8 grams of sodium chloride. One more example. Methanol Ch3OH is the simplest of all the alcohols. It is synthesized by the reaction. So they give me the reaction. That reaction has a coefficient in it, so I know that the reaction is already balanced. If I have 500 moles of CO and 750 moles of H2, which is a limiting reactant? So I'm going to take 500 divided by 1, 750 divided by 2, which one is a smaller amount? So 750 divided by 2 is 375. That is less than the 500 divided by 1, giving me 500. So hydrogen is my limiting reactant. So how many moles of the excess reactant remain unchanged? So the excess reactant is CO. Well, if I have 500 moles, how many moles are actually used? So I can start with my limiting reactant, convert from my limiting reactant to my excess reactant, and that's going to tell me how much I need to use. So out of the 500 moles of CO, I need to use 375 moles of them. So that means I have 125 moles of CO that are not used, so that I have as extra. So if you take what you have, subtract what you used, which is based on your limiting reactant, that tells you how much extra you have. Now in letter C, we're looking for how many moles of our product we're going to have. So again, we have to start with our limiting reactant. We're already in moles, so we can go to the mole ratio to switch our substance, the coefficients. Now I'm at moles of my product, which is what I was looking for, so I'm actually done here, and it's 375. Now, why is the moles of my product the same as the moles of my excess used? And that's simply because the mole ratios were the same. It's not always going to be the same.